The other section we will review is reinforcement detailing, 9.7. In 9.7.1.1, we first have stipulations for concrete cover. This section takes us to section 20.6.1, where table 20.6.1.3.1 specifies a minimum of 3-inch cover for concrete cast against the ground. You may notice this is also 7.5 centimeters, which is what is specified as coverage in the standard drawings. Section 9.7.1.2 discusses development length. The basic definition of development length is the amount of bar that is needed to be embedded in the concrete in order to achieve its full yield strength. This is most relevant for the erection hooks, so it is analyzed in the construction analysis portion of this course on rebar development length. Section 9.7.2.1 gives us minimum spacing, 9.7.1.3 gives us minimum spacing of parallel bars and stirrups. It leads us to section 25.2.1, where we get the parallel bars should be the greatest of 1 inch diameter of the bar or for 4/3 diameter of the aggregate. Diameter of the aggregate is the largest aggregate diameter, and we know this will govern as the largest allowable aggregate in the concrete mix, as given by the EIA Bridge Binder Volume 3, is 5 centimeters. So we get a maximum value here of 6.67 centimeters for minimum spacing between parallel bars. And then we'll also make a quick jump to 9.7.6.2.2 for the maximum spacing of shear reinforcement, which should also be the lesser of D/2 or 24 inches. So we have a minimum spacing of parallel bars, and we have a maximum spacing of shear reinforcement. And that is going to be that dimension that is called out as 30 centimeters or 11.8 inches in the drawings. So we are just under D/2 for the A2 medium anchor, which is going to have a D value of around 25 inches. So the maximum spacing would be 12.5 inches. Also in section 25.2, we see our minimum inside bend diameters. This is a detailing concern because the minimum inside bend diameter needs to be monitored in the field. All standard drawings are marked with the minimum inside bend diameter, and this information comes directly from tables 25.3.1 for bars in tension and 25.3.2 for stirrups. The tables are really easy to follow and pretty self-explanatory, so I won't recreate them below. But you can go to these tables to confirm the values that are on the standard drawings, referencing what the minimum inside bend diameter of the rebar should be. And if you're a reinforcing bar, you want to be really careful to make sure that the rebar meets this minimum bend diameter, but that you're not bending it back and forth to be checking that, because every time you're bending the rebar, it's going to be getting more brittle and more likely to fail.